Hello, in this talk I will briefly introduce our paper towards automated distillation, a systematic study of model distillation methods in natural language processing. I'm Hao Yuhe from Northeastern University. I'm honored to do this work with Xin Jianshi, Jonas Muller, Shengzha, Mu Li, George Carapis at Amazon Web Services. Knowledge distillation is a method to transfer knowledge from a large teacher model to a small student model. The motivation of KD is to reduce the memory costing and also pertain the teacher performance or accuracy. There are a lot of works have been proposed in knowledge distillation to achieve effective KD algorithms. However, given these different KD algorithms proposed, we find out that they are just improving variants or components in the KD training pipeline. The area still lacks a systematic study to understand factors or components underpinning the optimal performance, especially for new downstream tasks. If we have a systematic study, it can also help us to design an automated KD algorithm that recommends strategies or KD strategies for new datasets. To achieve this, we first introduce a framework called Distiller with 4 configurable components: data augmentation, objective function of intermediate distillation, layer mapping, and also objective function of transferring prediction layer logics. With the Distiller framework, we can cover most of the previously proposed KD algorithms by changing the techniques used in these 4 configurable components. And also with the large search space of Distiller, we conduct large-scale hyperparameter search experiments. With the experimental results, we also propose an auto distiller. The auto distiller trains a model to predict the distillation ratio, which is the enhancement of this distillation over fine-tuning. Predicting the distillation ratio, the auto distiller can recommend best configurations or strategies to achieve better distillation performance, given a new dataset with the extracted features and also distillation configurations in the large distiller search space. We find out that the experimental results shows that if we give the auto distiller more and more training data, the prediction of auto distiller becomes more stable and also avoid producing trivial strategies where distillation is worse than fine-tuning. Also, because the motivation of our auto distiller is to use it on unseen or never seen before downstream tasks, we also used our auto distiller on 2 never seen before datasets in our experiments. The results shows that the auto distiller outperforms random search on both tasks. The strategies recommended by auto distiller performs a much higher distillation ratio than the randomly selected strategies. To summarize, our work proposed a meta and configurable distillation pipeline called Distiller. And also with the Distiller search space, we propose a proof of concept automated distillation tool called AutoDistiller. The performance of AutoDistiller outperforms the randomly sampled policy or strategies on 2 never seen before datasets. And it shows its potential to become the first attempt towards automated knowledge distillation. In the future, we will compare our auto distiller to different hyperparameter optimization, and also make this auto distiller pipeline an end-to-end method learning. Thanks.